Arsenal sent me a message saying
I guess I will record this one more day just in case. Group continuous data. We had discrete data is all we've dealt with so far, but we've got to throw in continuous data today. Continuous data does have decimals and whole and fractional parts to it. So when you make your bar chart, for example, the one big difference between discrete and continuous is you put the bars together for continuous. Why would you do that? Why did we leave a gap with discrete data? Why would we put them together for continuous data? Too long? Yes, whole numbers. Remember, this is discrete data we did before. Whole numbers. Where does this guy stop if it's whole numbers? 9. And the next group, is there any like 9.1 or 9.2 guy in there? No, there's no way. So that's why there's a gap here. What's happening with continuous data, however? With continuous data, could there be like a 6.2 and a 6.9 and a 6.999, perhaps, all the way out to 7? So with continuous data, you put the bars together because the data does go, it's not just whole numbers, it can go 4.9, 4.99, 4.999, and then 5. So you put the bars together. Sample of 20 juvenile lobsters was randomly selected. This is right out of your book. From a tank containing several hundred. The length of each lobster was measured in centimeters and the results were shown. So they just picked these 20 out of hundreds of lobsters as a random sample. Is this continuous or discrete? Are there fractional parts?
Yes.
Yes, because you're measuring how long the lobster is. So yeah, when you're measuring, you could definitely say a decimal, 7.3 centimeters or whatever. To organize this data, we would put it in a frequency table, and they organized it to put it in groups. Most bar charts should have 5, 6, 7, 5 to 10 bars. So they actually put it in 1, 2, 3, 4, 5 groups. And this worked out nicely because what is the smallest lobster here? Maybe 3.1. What's the longest lobster?
7.
Maybe. Okay, so it worked out nicely here that we could just say all the lobsters that are 3 centimeters can go in this one, and the ones that are 4 centimeters can go in this, 5, 6, and 7 centimeters can go in this one. So this one worked out nicely because we've just got these cute little categories with no decimals in there that works, and you get a 5-column graph. And then you put them in, you do a little tally table, you can do a little tally column and then a frequency column, and put them on your bar chart. What does this little lightning bolt mean? Why is there a little jog here?
It jumps from 1 to 3.
Yeah, if it jumps, if you got a big jump at the beginning, you put a little lightning bolt on the axis down there to show that there is a big jump here out to 3 and you're starting with 3. Okay. What about these categories? Where is a 4 exact centimeter lobster going to go? Where is 4 exactly going to go? Is 4 going in this group or is 4 going in this group? Second group because? Good, you've got the equals going there, don't you? So this means right up to 4, but still staying completely less than 4. Less than 4 means 3.9999 can still go in here, but once you get to 4, the equals 4 guys have to go into this one where you've got the equals going in. When you organize your categories, you're going to have to do the same thing. You're going to have to stop less than somewhere and equal to at the next step. So you'll know where exactly 4 will go. Exactly 4 will go in this group. If you catch 1,000 lobsters, approximately how many would you expect to be less than 6 centimeters? See if you can figure this out. How many lobsters do we have here? We've only got a sample of 20. How many of those 20 were less than 6 centimeters? You can look here, or you can look here. Which lobsters are less than 6 centimeters?
14.
Are these guys less than 6 centimeters? Are those less than 6 centimeters? Are these less than 6 centimeters?
Yes.
Are these? No, these start being 6 or more. So out of just this sample, how many of the sample were less than 6 centimeters? 11, 12, 13, 14. 14 out of 20. What if you have 1,000 lobsters? How many of those 1,000 lobsters would you expect to be less than 6 centimeters? Work that out.
Eight? Not sure if it's right.
These are the questions that separate the 6s and the 7s from the other IB scores is working on. You can get like 1 through 5 by making your table nicely and getting your chart going and all of that, and you'll get a 5. This is where you get your 6s and your 7s, is answering questions like that. Okay, so this is a representative sample. 20 lobsters. How many of my 20 lobsters fit this requirement? Less than 6 centimeters. 14. 14 out of. So is that fraction of these lobsters working for what they want? Yes. What if you have 1,000 lobsters? Will the same fraction apply to those 1,000 lobsters? You would hope that at least it would be close. And what is that fraction of 1,000 lobsters? Yeah, about, who got something like 700? Okay, good. Choosing the class sizes is the hardest part of making a grouped continuous frequency table. How big do you want to make your groups so that you get a nice number of bars, so that you get 5, 6, 7, 8, 9, 10, something like that, number of bars? Well, the first question you need to ask is, how many bars do you want? If you only have 10 numbers that you're sampling, would you make a bar chart that's got 10 bars? If you're only sampling 10 numbers, would you decide to have 10 bars there? Probably not. There's not enough data to make very many high bars if you have 10 pieces of data and you're putting it and trying to get 10 bars out of it. So, but if you have 1,000 pieces of data, then they might spread nicely between 10 bars. So the more numbers you have, the more bars you can use to differentiate your column graph. Okay? But if you've only got a small number of data points, then you would want just a small number of bars to show it. And general rule of thumb is that you take how many numbers there are in your sample and find the square root of that. This has 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 by 6, 60. This has 60 numbers. How many bars are you going to get for your bar chart out of 60 numbers? Find the square root of 60. The square root of 60 is about,
1.7.
yeah, 7 times 7 is 49. 8 times 8 is 64. So 7 or 8 groups. Okay, so how are you going to arrange your group size so that you get 7 or 8 groups? You could have 6 groups, or you could have 9 groups, but it should be something around 7 or 8. 6 would be still okay, or 9 would still be okay. Where would I start?
Lowest number.
Good. The lowest number, sort of, where is my lowest number? Yeah, there's a 20 there. Anybody see anything less than 20?
Yeah.
Where? Okay, so maybe 20 is the smallest? That's nice. What's the biggest?
54.
50?
58. 58.
Okay, there is a 58. There's several 58s. Okay, looks like 58. So, my categories need to start at 20 and go up to 58. How big should each little category be so that I end up with 6 or 7 or 8 or 9 little groupings? Yeah, what?
You can go 20 to 30, 30 to 40.
Okay, we could do a rough guess. Okay, we could say, let's try, 20 to 30, 30 to 40, 40 to 50, 50 to 60, 60 to 70. Well, where did we need to stop? There.
By 5.
So how many little categories will we get if we did by 10s there? Ooh, we'd only get 4 bars. So 4 bars, so that's a good idea. So at least we started trying something.
Get it by 5 now.
Yeah, give it by 5. So let's try that. So 20 to 25, 25 to 30, 35, 30 to 35. So how many did we get? 1, 2, 3, 4, 5, 6, 7, 8.
It has to be like an
same number, 20 to 25.
Exactly.
Yeah. We'll have to fix these categories. I'm just trying to get an idea of how big to make them. And then we'll fix, because we do, like Niall is saying, we have to figure out exactly, is 25 going in this guy or is 25 going in this guy? So we need to fix these, but at least we're getting a better idea. Did that work out okay? 1, 2, 3, 4, 5, 6, 7, 8. Did we say 8 bars was okay?
Yeah.
Okay, so that is something we could try. Did anybody think of seeing how far it is to go from 20 out to 58 and divide it into 6 or 7 little parts and see how big each one should be? Anybody think of that? No. How far is it from 20 out to 58? 38. And how many little bars did we say we needed? The square root of 60 is approximately 7 or 8. So divide this by 7, what do you get? About 5. And how big was each group in the end? Gerard gave us a plan for 5. And, sorry, Gerard's little brother. Sorry, Stefan. Stefan gave us a plan for finding, just trying something and trying something. But if you do it more mathematically, you could say, well, I need to start at 20. I need to go out to 58. How big a span is that? 38. How many little bars did we want? 7 or 8. Divide that span by 7, and you see each group might be about 5. Okay, so what are we really going to write here for our groupings? What was the sample from the last chart that they?
25 is less than or exact to 30.
What did we put?
Less than or equal to.
This side was the less than or equal to. Okay.
Is it L? This less than
And what did they put here?
1.
L. Or 1.
L for length, or yeah,
that's just
or X,
whatever.
some variable.
Yeah.
And then
Banana.
less than 25. And this one would be 25, less than or equal to L, less than 30. Okay?
So we're gonna do 10 then?
So these are 5. From 20 up to 25, 25 to 30. If we use groups of 5, we ended up with 8 bars in our bar chart. 1, 2, 3, 4, 5, 6, 7, 8. So we decided on 5 being okay. So make a little chart like this, please. Make a little chart like that.